Okay, apparently I'm going to do linear transformations take 2 because apparently my first take I decided to really mess up with how I was explaining things. Oh, good grief. Anyways, I hope this will be better. So what we're going to do today is we're going to investigate changes to the parent function, parent linear function, which is f of x. What does that look like, you say? Oh, hey, look, there's a graph, there's a calculator, there's how you do it. Okay, so keep in mind this is going to be done on the Inspire, but you can see here, notice how it says f of x is equal to x. This means, what it means is that we're going up 1 over 1, up 1 over 1, and we go through the point 0. But notice how it kind of makes this 45-degree angle, so keep that in mind. Alright, so let's look here for a second. You can see here F1, F2, and F3. These are 3 different lines, and I'm trying to see that you see the transformations. Do you notice something? Here's the parent function right here. The question is, did it move? If you notice, on F2 it went up, and then on F3 it went down. And all I did was add or subtract. So what we say here is this. The function, when you add or subtract a number, notice how it's written, x plus or minus a number. If you add, you vertically shift up. You subtract, you vertically shift down. Alright, here, I'm going to back this up a little bit. Okay, here we have a bunch of graphs, tons of graphs, lots of graphs, lots of graphs. But you can see here, they all go through the origin. The only thing difference is like how steep the lines are. Now, if you notice, the 2 is in front, it's that red line. F of 2, this one right here, is this red line. Okay, so, and notice how it's kind of steeper. Like if I say here's a line like this, this is steeper, that's what that's kind of implying. Okay, so the red one, F of 2, is steeper. And what we say there is that's a vertical stretch by a factor of 2. So you can actually just say that's a vertical stretch, and they tell you what the factor is by the number in front. When you have a negative, the first thing you should say is, when you see a negative, is that that's a reflection, because that makes the line go down, as you can see right there. It's still a vertical stretch because of the number 2, but the reflection happens because of the negative, the minus, or the negative in front of the 2. Okay, and then when you have a number between 1 and 0, a fraction like 1/2, then you have a vertical compression, which means, well, it kind of flattens out. That's why you can see this purple line looks lower than the parent function blue line. So you got to make sure you understand this vocabulary, because, guys, I'm introducing this idea because we're going to see it today, and then we're going to see it again when we do quadratics, and so we're going to like start seeing this happen often, and you'll actually see this terminology in this format all the way throughout, even through Algebra 2. Okay, now you can see here there's some changes here with parentheses, and they really don't make too many big changes, but when they're in the parentheses, we talk about being horizontal. In other words, we're making the change to the x. Here, outside of it, we're technically, in a sense, making changes to the y part. Here, supposedly, we're making changes to the x, so we're going to make horizontal changes. Now, to sum all that up, and you're going to see this. Now, keep in mind, like this one is still multiplying, so this is a horizontal stretch or compression, but this time we say this is a, if you take the reciprocal of this 3, you would get 1/3. So since that's between 0 and 1, that's a horizontal compression. Now this is something that will make more sense the more we get exposed to it, but it's going to be kind of like, what are the heck are you talking about right now? But we'll see. But let me sum this up, because we really are going to see a lot more of this about when we're looking at it. Okay, so you've got this. When we're dealing with, when you're outside, remember, outside the parentheses, we're dealing with the vertical part. So A A and D are dealing with vertical. B and C are dealing with horizontal changes. In a linear function, that's not really that big of a deal, but I want y'all to get used to what we're covering here. A negative in the very front means there's a reflection. If the A number is greater than 1, you have a vertical stretch by whatever number that A is. If it's between 0 and 1, it is a vertical compression. If you have a and if you look at the D, if the D is being a plus, this means a plus is a vertical shift up, minus is down. So what does the B and the C mean? Well, that's a little bit special there. Okay, so I'm going to pause this real quick because I'm going to erase all this part and just focus on the B and C. Never mind, I changed my mind. Okay, so here's how this works. Let me focus on the C part first. This is a horizontal shift. Now here's the weird part. A plus means you horizontally shift to the left. A minus means you horizontally shift to the right. Okay, so in parentheses, you got to kind of think opposites. So even here, on this, you've got to think opposites. Before you look at the horizontal stretch, because this is about horizontal stretch, okay, you need to take the reciprocal. So say 1 over B. Okay, and then, again, if that's the case, that's a... If that number is greater than 1, it's a horizontal stretch. Keep in mind, 1 over B just means take the reciprocal. If it's between 0 and 1, that's a compression, horizontal compression. Okay, so that sums this up just fine. There you go. We will talk about this and try to see this a little bit more. My focus is going to be on the vertical stuff, but we're bringing in this idea about horizontal because of what we will do in quadratics later on. Anyways, that's it for today. Thank you very much.